and actually one of the most important theorems is the Pythagorean theorem. So A and B, these are what are called legs of the triangle. Legs of the triangle, okay? So the legs shoot out from the 90-degree. Does that make sense? The legs, and it's kind of something you got to write down.
Yeah.
They come out from the 90 like that. All right. C is the hypotenuse.
Okay. Hypotenuse.
Yeah.
What does that
So,
mean?
well, it's across from the 90 degrees.
Okay.
Okay. So you have a leg, and hypotenuse. So you got to be careful here that you correctly identify which are the legs and which are the hypotenuse. Okay. And the relationship here, it's not a sophisticated one. It's a squared plus b squared equals c squared.
And that's the Pythagorean theorem?
Yes. Yes. So let's just see this in action here. So let me give you a problem here where we have A, which is 3, B, which is 4, and C, which is 5. So what we're going to do here is put these numbers into the formula. So it's instead of A, it's 3 squared. Instead of B, it's 4 squared. Instead of C, it's 5 squared, like that.
It seems pretty easy because it's just adding then?
Well, you got to square first, order of operations. So it's 9 plus 16. Does that equal 25?
Yeah. I think so.
Yeah, so 25 equals 25. So the way the Pythagorean theorem is actually used is they don't give you all 3 sides. They give you like 2 of the 3 sides. Okay, so that they might,
Do
they would
you
use,
need to solve for C usually?
well, you could actually solve for any of them, but we're going to do this problem where you solve for C. Okay.
Okay.
So again, it's a squared plus b squared equals c squared, like that.
Triangle 90 degree. A equals 6. C. Let's see, so 6 squared plus 8 squared equals C squared. Okay. Six times.
So, please use a calculator. This isn't mental math. I mean, your goal here is to work the problems. 6 squared is 36. 8 squared is
So is
64.
100 is C?
Well, no, it's c squared. That's
Oh,
the common mistake, and you want to make a note of that because a lot of students do what you just said. They say, "Oh, it's c is 100." No, c squared is 100.
so it would
These,
be so
you,
it would
you have
be
to take the
10,000.
you have to take the square root. Square root.
Oh, how do I do that
Well, it's a
again?
button on your calculator. Um, it's got kind of this look to it.
And
Okay. D equals 10. Good.
I thought it would be like the same as the other two, like where when you square it, like 100 times 100.
Square root is going the other way. So
Okay.
I would get this down in your notes. I'm going to pull up one of my practice sheets on my website that will allow us to um, go through this. So give me just a moment to pull that up. So here is a new problem for us to look at. All right. A equals 5 and B equals 12, solve for C. So it's good to kind of put those in here. B is 12, C is unknown. And then you always want to write the Pythagorean theorem, A squared plus B squared equals C squared. And so you put those numbers in. You put those numbers in 5 squared plus 12 squared equals C squared. So go ahead and square the 5, go ahead and square the,
Okay, so 5 times 5 equals 25 plus 12 is 144 equals 169 and square root of 160. No, that's 168. Is C equal 13?
D equals 13. Very good. Okay. So let me have you try another one here on your own. Okay.
Square. Times 64. 64. 49. Add to C equals 17.
Yes, good. Okay. So 8 squared plus 15 squared equals C squared. 54 plus 225 equals C squared. C equals 17. Good. Okay. Now the other type of problem you'll see, I'm going to grab that now for us to look at, is because you were asking about this earlier. It's like, was it always A and B to get C? No, they could give you, they just have to give you 2 of the 3 sides.
But you'll always have 2. And then
We
they'll
can
tell you which one to, you'll know which one to solve for.
we can presume that, yeah.
Okay. Like I wouldn't be having to do any like crazy trying to find both of them off
That's
of one number, right?
No, that's a different class. So again, the good thing to do is to label the sides, okay? And write the equation. A squared plus B squared equals C squared. You don't know A, but you do know B. B is 4 squared. And you know C, that's 5 squared. Okay. So what you do is you square the ones you know. Okay. Square 4, square 5, and notice that your variables in a different place.
So it's different a little bit.
Yeah, you have to subtract. So which side has the variable? 'Cause we've been solving equations for a while now. Which side has the variable, the left or the right side?
Left.
Left, which means that's what you undo from. So you undo this 16 by subtracting 16. And then you have A squared equals 9. Okay, and so then you take the square root of both sides. So A ends up equaling 3. So this is definitely a good problem to get down in your notes to think about.
Equals 5 squared. A squared plus 16 equals 25 minus 16. And then you square okay, I have it written down.
Okay, so let's have you try one here. Really similar, basically just different numbers. And
A equals 5, C equals 13, and then A squared plus B squared equals C squared. Write that on the top. And then B, and then 5 squared, B squared equals 13 squared. What no, 13 times 169. So you would subtract 25. Let me see.
you would subtract 25 from 169.
All right, so 144 And then square root of 144 is 12. Is b equals 12?
Yes, b equals 12. Very good. Okay, that's excellent. Let's have you do one more and then we'll switch to kind of a new-ish topic. That's actually gone really well. So so same thing here. If you want to solve through that, please.
See. So for b, we do 5. And 289. Subtract 2, 9 minus 225 equals 64, and then square 64. C, no, not C. Does B equal 8?
Yes, very good.
Yay.
15 squared plus b squared equals 17 squared. 225 plus b squared equals 289. B squared equals 64, so b equals 8. Very good. Okay, so those are the two main types of problems you will see. We're going to next look at perimeter and area of a triangle, which is related to the Pythagorean theorem. So for example here, let's say I give you a triangle like this, and I tell you the sides are 3, 4, and 5. Okay, so there's two things we're going to be finding. The first is perimeter. You remember what perimeter means? You
Like the
ever heard?
surrounding area?
You can't,
No,
it's
that
different
that
than
would be
area.
area. Yeah, I'm
Yeah.
trying to think of what the big difference between them is.
So I call it a walk around. Imagine you're on a date and you want to walk around the triangular shaped park. So you go down, right, and then back. Like you walk all the way around.
And then what is the difference for area?
We'll get to that. So the perimeter
Okay.
in this case is 3 plus 4 plus 5, which is 12. Okay. So the area is more complicated. So you want to get this down. The area is a formula. It's base times height divided by 2. Okay, so, and for a while here, I'm going to actually label the base for you and the height to make this less complicated. Yeah, when you're learning something new, when you're learning something new, we want to give you most possible success we can. So in your problem here, the base is 4, the height is 3, and then you divide it by 2. So you first multiply and then divide.
And the perimeter is just adding all the sides.
So give me the area here, please.
Okay, so the area is 4 times 3 divided by 2.
Yeah.
6.
Good. Good. Right. So here's the thing though. There is wow, these don't have. So I don't want to say this. We'll do another one here. They're supposed to have units. Okay, so let's say this is 8 meters, 15 meters, and 17 meters. Okay, so when you find the perimeter, you're adding up all of the lengths. So it's 8 plus 15 plus 17, which ends up being 40, but you have to put the units here at the end.
So would it, is there anything different you have to do about that, or is that just like it would
No,
mark
I'm
it
just
false if
saying,
I?
I'm just saying put the units in. Put the units
Okay.
in. And for area, it's a little bit different. So for area, again, it's still base times height divided by 2. This is the base. So the base is what it sits on. It's like your butt. You sit on your butt. At least that's what I do. The base is what it sits on. The height is obviously how tall you are. So this is 15 times 8 divided by 2. Would you calculate that for us, please?
See. 60.
Okay, now this time, this is what's different. It's meters squared or square meters. Now, I don't think you're going to get any problems where like you have to put units in, but you want to know the difference. It's just, it's like the English language, you know, we want to be able to talk and communicate with each other, not, you know, be foolish when we're around people. I don't know if that makes any sense. You know, you want to use the right words.
Yeah.
Okay. So,
It's like adding the negative signs if it's a negative answer.
yeah, exactly. So the next thing I'm gonna do here is I'm gonna like, these are not correct triangles, but I just want to use them for purposes of us just doing some problems here. So these numbers are not correct, but just like meaning like they don't actually work, but just go with them. 9 centimeters, 12 centimeters. Actually, this one will work. And then 15 centimeters. Okay. So I want you to find the perimeter and the area for me.
Let's see. What are- Perimeter is, it's 9. The perimeter be 36 centimeters.
Okay, good.
And then the area, let's see.
This is the base, and this is the height.
So 9 times 12 divided by 2.
Okay, yep, keep going.
Divided by 2. So it would be 54 centimeters squared.
It's really good. Okay. So we're looking at a new problem now. Something you might see. This is closer to what's in your book there. So not all the triangles are going to look the same. This one looks a little bit different. The triangle is the outer edge here. Hopefully you can see that. So first, give me the perimeter, please. calculate the perimeter.
Does anything change about the height with the angle being in the middle? Is the height still
Nope.
on the left?
The
Is it still
the perimeter is
4.2?
the perimeter is a walk around. You walk all the way around the triangle.
But for the area, does it
Well, I'm
change
not
it in anything?
I'm not asking for the area. We'll get to that.
Oh,
Like we got to do one thing at a time.
okay.
Right foot out in front, then left foot. We'll
Let's see, 4.2. 0.6, 3.4 equals 12.2, what was it, feet? 12.2 feet.
okay. All right, now you're on to a really good question. So the area is base times height divided by 2. Can you tell me which is the base in this problem?
3.4.
Yeah, that's the base. And you were onto it. I just didn't want to I didn't want us to get too far. This is the height here, and it is given as 4 in the problem. Okay, so it would
That's
have been given. I just didn't want to overdo it on the first one, meaning having too much.
okay. So that would have been, if it's something like that, it'll be given.
Yes, of course. Yes.
Okay. Height 4. So the area is 3.4 times 4 divided by 2. So is the area 6.8 feet squared? Is that how you would say it?
Exactly. Yeah.
Okay.
Okay, very good. So let me give you a problem to try from start to finish. Should make use this one over here on the right. So give me the perimeter and the area, please.
Shoot. 1.1. Two, 2 perimeter.
I'm gonna step away for a minute. I'll be right back.
Okay. 6.3 feet. Area.
I'm back if you have any questions or want to give me those answers.
Uh, for the perimeter, I got 6.3 feet, and for the area, I got 1.21 feet squared.
Because your area is correct. My
Is the
guess is with the perimeter, you used all the numbers, but you only need to use 3 of the numbers.
Oh, I don't need the height, huh? Okay. Yeah, that's where I got confused. I added the height too. I was just going all the way around with the numbers instead of going around the sides. I was just going around the numbers. So 1.7 plus 1.3 plus 2.2. So it would be 5.2 feet. Is
See if
it
I can find
5.2? Oh, okay.
see if I can find a different problem here. Maybe, actually, let me go back and look at your problems and see if one stands out here. Yeah, there's actually, let me go ahead and download. There's a couple that we can do here. Yeah, you probably are gonna want to resend these. I think maybe you'd send them as the lower image quality. I don't really understand,
Yeah.
but
I don't know why they sound like that, but I can resend which ones exactly
I
were the
don't
ones.
know. Let's just go with actually, this is a completely unreadable. This is
Wait,
13, this is 6, and this is 7.8. This is 10. So I guess do the perimeter and the area again for me, please.
that one. Resend. Perimeter and area. And then I'll send, I know we did circles. I know we went over circles briefly once. I think I still have some notes written down, but I don't remember how much circles we went over.
Okay, yeah, we'll definitely get to that. I mean, we got a few more things to do here before we get to circles.
Then I will resend. My phone camera no.
Oh, you don't have to resend. Just if you want to work on this problem, it'd be good. The numbers are
Oh,
all here.
okay. Sorry, I was trying to resave. Okay. Get right down. So for the perimeter for this one. Area is the perimeter 30.8 and the area 39.
Yes. There's no units this time, so not much to say there. Okay. So let's look at now rectangles and squares. We'll start with squares. So squares have the characteristic that all the sides are the same. So I only have to tell you like that the side is 12 inches, for example, and then you know that it's 12, 12, 12, and 12. Okay, is that okay so far?
Mm-hmm. Like all sides, so all sides on a square will always be the same.
Yep,
So it would just
yep.
be like 12 times 4.
Right, so you can either add them all up or do 12 times 4, which is 48 inches. The area though is slightly different. It's base times height. There is no division by 2. So it's 12 times 12, which is 144 inches squared.
Squares always the same.
All right, so
And
here is,
the
we'll
rectangles
get,
have like
we'll get,
two matching sides.
yeah, we'll get to that. Let's do an example or two. So I want you to find the perimeter and the area, please.
Three. So the perimeter would be 12.
What are
And
the
then the
units?
area would
What
be,
are the units of perimeter?
oh, 2 centimeters. I didn't notice the centimeters. 2 centimeters, and then the area would be 9 centimeters squared.
Not that difficult. Let's talk about rectangles. So rectangles, like you mentioned, they have opposite sides are congruent. So I have to give you two of the sides. So I have to tell you like that this is 6 and this is 14, for example. We'll go feet, I guess. So then you automatically know that the other one is 14 feet and that this one is 6 feet. And so the perimeter is 6 plus 14 plus 6 plus 14, which ends up being 40 feet. The area is still base times height. 6 times 14, 84 feet squared.
So there's no dividing by 2 with
That's
the,
right.
okay.
Nope.
That's easy.
Yes. I mean,
Easy to get
this
squares.
this type of stuff is not overly difficult, but you got to know the formulas, right? You got to know the formulas to be able to answer these questions. So I want to give you some practice here. Maybe give you 3 problems here. Okay, and I'm going to ask for different things. So this one, this is 18 centimeters, and this is 24 centimeters. And I want the area of this one. This is a square. I'm going to tell you that the side is 2.5 inches. I want the perimeter. Yeah, let me have you just do those two. Kind of, this is the mixed review of problems.
So let's see, triangle. What's this side of the triangle?
You don't need it. What am I asking for here?
Oh, never mind. I didn't realize there's only one of them. Let's see, 18 centimeters. 24 centimeters. Let's see. Oops, area equals divided by, or no, 18 times divided by 2. 216 centimeters squared. And then this for the square.
What's your final answer on this one? Sorry.
216 centimeters squared.
Okay.
And then for the square, 2.5. So, and then the square perimeter is 10.
10 what? What are the units?
Oh, 10 centimeter.
Inches.
Oh, no, never mind. Inches.
Yeah, I mean, my
Inches.
handwriting isn't great, but yeah. So there's like a couple of things that are going into this. Let me see. So I grabbed other problems there. It's really terrible. We can't say it. Okay. 20 and 32, 20 and 32. This is a rectangle. I'd like you to find the perimeter. Let's do yards.
Okay, yards. 20, 32. And then 104 yards.
All right, how about the area?
All right. 20 times 2. 640 yards.
Yards squared.
Oh, yeah, squared. Forgot that part. All right. Area keeps the squared.
Good.
It was the dividing by 2 that we didn't do, not adding the squared.
So you've got to be able to, whatever you see, you have to be able to work with. So let me give you another one here to look at.
Triangle.
So what is the perimeter?
Perimeter, let's see, 7 plus 8 plus 4. So the perimeter is 19 centimeters.
Okay.
And then,
That's it. There's nothing else you can do on that one.
oh,
Okay.
okay, there's no like,
Yeah, there's nothing more to do.
okay, that's interesting. So some of them you can't get the areas on?
Yeah, they don't have everything available.
Okay.
All right, so just looking for some more questions to give you that aren't overly difficult. I don't want to jump into anything new. All right, let me throw a new one here in front of you. All right. All right, what is the area of this triangle? And remember, it's base times height divided by 2. And this is the base, and this is the height. Okay, so I want you to work that one out, and then I'm going to put another one here in front of you as well. I gotta just step away for another minute. So you could try both of these for me, please. I'll be
2 times
right back. Let me make it a little larger.
4.7. Oops, not centimeters, it's yards. Squared. Squared. Hello?
All right, I apologize for the delay. Do you have some answers for me on these?
For the first one, I got 4.7 yards squared, and for the second one, I got 23.1 yards squared.
Okay, so for the first one, yes, 4.7 yards squared, good. And for the second one, you said 23.1?
Yeah.
Yeah, great. Okay, so next time we can talk a little bit about circles. That's a big one. It looks like there's also trapezoids in your thing there. There's some
I'll take some better
parallelograms.
pictures and see if I can send ones that aren't like low res for whatever reason.
Yeah, that would
Or
definitely
next time.
help if you want to resend all those.
Okay.
So there's definitely there for another lesson or two. We should also do like what's called composite shapes and things like that. So yeah, give that a try, and we'll be closing out here. So let me go ahead and stop the recording.